Okay, problem set number 3 looks a lot like the others. Let's find some derivatives. What's the rule going to be? We haven't done e to the anything in the first couple, but we definitely know the rules. You should know the rules. What's the overarching derivative rule here? Well, it's two functions of x that are divided. It's a quotient rule. Let's write quotient rule out here. Because I bet as we write these rules down, we see the same rules over and over and over. It's just a matter of maybe six rules do we have? It took a whole semester to learn 6 rules, something like that. Our u is going to be e to the 1 over x. What's our u prime going to be? Well, it's going to be e to the 1 over x, right? E to the input, the derivative is the same, except chain rule, this whole thing. Well, 1 over x is x to the minus 1, so that's actually an exponent rule, isn't it? So we should make it negative x to the negative 2. So you can think of that as x to the negative 1, right? So that's what that's going to be. And what's our v? Our v is x squared. That's easy. So v prime is going to be 2x. That's extra easy. And the quotient rule is u prime v minus v prime u over v squared. So to get y prime, let's just plug it in. It's negative e to the 1 over x squared. That feels right. I just want to make sure that I'm writing it correctly here. It is u prime v, which is x squared, minus v prime u, 2x. I'm told I say that I feel too much. E to the 1 over x. So I'll try and pay attention to that. And that's all over, let's put a parentheses on that, all over v squared. So that would be x to the 4th. So of course this is going to cancel. What do I see here? I see negative e to the 1 over x minus 2x e to the 1 over x to the 4th. So of course we're going to take a negative e out. We should get 1 plus 2x, and that's over x to the 4th. That's a pretty cool looking derivative. I like that. Okay, what about the next one? The next one is, there's y's and x's all over the place. I should have wrote that there's an exponent rule in there, but I guess there really wasn't. The exponent rule is e is its own derivative, so I guess there is. I'll be more careful. Y plus x cosine of y equals x squared y. This is where most my calculus students fail, is when they see multiple x's and y's, they lose their mind. Well, let's just pontificize for a second here and think it through. What are we trying to find? We're trying to take a derivative. We want dy dx, right? So let's take the ddx of the whole thing, and we'll use implicit differentiation. So that's going to be dy dx here, plus product rule, u prime v plus v prime u. This is a multiplied function here, and y is a function of x, and so is this here. So there you go. U prime v, so that's 1, cosine of y, plus v prime, that's negative sine of y, chain rule, dy dx. So we got a product rule, we got a chain rule, and what's over here? V prime u, what's our u? That's x, equals another product rule, u prime v plus v prime u. U prime is going to be 2x, and then y, plus v prime dy dx, x squared. And these by themselves, so I guess we don't need those overarching parentheses, but it's not going to hurt. So what can we do? I think we should move this to that side, and move this to that side, so the dy's are everywhere on one side. Dy dx minus dy dx x sine y minus dy dx x squared equals negative cosine of y, we subtracted that over from here, plus 2xy. So if I take a dy dx out of this, I get a 1 minus x sine of y minus x squared equals 2xy minus cosine of y. So then we could just divide, and we'll find that dy dx, it's not particularly clean, but I think we're arriving at the answer, equals cosine of y over that 1 minus x sine y minus x squared. And that's that derivative. It's kind of cool looking, really. But that is the right answer. Okay, let's go to the next one. For the third problem, we need to actually be careful. Y equals the square root of arctangent of x. Now, I have derived this in the past. Look back to the explainer video for it, but I'll just write it over here. d dx of arctan of x. I don't care if you write it this way or if you write it this way. They're the same thing. That's equal to, I have to do it kind of from memory here, but I believe it's 1 over 1 plus x squared, whatever the input is being x. So if I want to take this, the first thing I would do is rewrite it as arctangent of x to the 1/2. This is a power rule first. Y prime is 1/2 arctangent of x to the negative 1/2. And then chain rule, inside function, would be the 1 over 1 plus x squared. So what do we get here? I get y prime equals 1 over 2 root arctangent of x times 1 plus x squared. Like that. That's pretty ugly, but I think that's correct. So you can write it in any syntactical form you like, but I don't know that it's going to get simpler than that. So you're probably going to get a cheat sheet for that one when it comes to the arc tangents and arc sines and stuff, but I think you should have to derive it. I do. It's actually pretty fast once you learn it. You do it like 2 times. My hound is snoring. You do it like 2 times, and that's all it takes before it's in there forever. How about this guy? Well, here's clearly going to be some chain rule action. Yeah? So y prime, what's the derivative of tangent? I think we all know that's secant squared. I really prefer to call it 1 plus tangent squared, but I know your test is going to be secant squared. So I'm going with it. 1 plus t squared times chain rule, derivative of the inside. Derivative of the inside. How do I take the derivative of the inside from chain rule? We got a trig rule. We got a chain rule. That leads us into the quotient rule. See how few of the rules there really are? We've been doing the same rules over and over. So let's take this out here. Let's take this out here. What's our u? That's t. U prime is 1. V is 1 plus t squared. V prime is going to be 2t. The quotient rule is u prime v minus v prime u over v squared. You should have said that aloud to yourself 1,000 times through these videos already. Surely you're not listening to the sound of my beautiful voice and doing nothing else. U prime v, u is 1, so I just left that out, minus v prime times u, that's t, over v squared, 1 plus t squared squared. So what do we end up with? We get a 1 plus t squared minus 2t squared. So we get a 1 minus t squared over 1 plus t squared squared. Yeesh. Okay. So that'll go right into our y prime that we've already solved before, so we can just put that in front. We'll say secant squared of t over 1 plus t squared right in front like that. That'll be our answer right there, I'm pretty sure. Let me have a quick look. Yeah, I believe that is the correct answer. So these four are actually pretty fast whip through. Let's move on to the next block of problems.